Hi there, and welcome to Telefunken. In today's video, we're going to discuss the calibration and tuning of the vintage Sequential Circuits Pro 1 analog monophonic synthesizer. If you have a Pro 1, are thinking about buying one, or simply are interested in vintage synthesizers, this video is for you. The calibration and tuning of the Pro 1 is discussed in Section 5 of the Technical Manual, which is widely available online. Although you don't need any special equipment, a good voltmeter and an oscilloscope could be helpful. If you don't have an oscilloscope, at the bare minimum, you'll need either a tuning fork or a frequency counter. But in my experience, an oscilloscope can be quite helpful as it allows you to see what's going on even if you can't hear it. There are 8 elements in the calibration of a Pro 1, and although we'll discuss each of these in today's video, we won't be touching the DAC scaling or adjusting the VCA balance. These two settings are adjusted using trim potentiometers that are only accessible when the PCB is removed from the instrument chassis, and in this video we'll be servicing a fully assembled instrument. All of the other adjustments can be made by accessing the trimmers through holes in the chassis. So without further ado, let's get started. We're going to go through the Pro 1 tuning, and the first thing we're going to do is approach the service manual DAC scaling. And this is not normally part of the tuning procedure, but it's an important part of ensuring that the DAC is actually working properly. This is described on page 5-1 of the service manual. And we've connected a digital multimeter here to the CV out jack. And we have an oscilloscope connected to the output of the synthesizer. And first thing we're supposed to do is hit a C0, the low C, and that's our low C. And we're looking for the voltage here. So it's not important what the synthesizer sounds like at this particular time, but rather what that voltage is associated with the low C. And that's currently 91.6 millivolts, 91.7 millivolts. And what we're supposed to do is hit a high C. And because this is a 1 volt per octave keyboard, we're looking for an additional 1, 2, 3 volts. So we should see 3.0917 volts or 3.092. We see a little less than that. So we're off by about 4 millivolts. And so if we wanted to ensure that we had absolutely perfect DAC scaling, we would open up the synthesizer and adjust the DAC scaling potentiometer, which is located roughly in around this area here. There is not a hole for adjustment of this potentiometer in the surface of the synthesizer. This is a single turn potentiometer with very limited sensitivity. And so I'm not going to touch the DAC scaling for now because I believe that I would not be able to get it any closer to where it is right now without replacing that single turn potentiometer with a multi-turn pot. We may revisit this at some point in the future, but for now we'll just leave it where it is and move on. So the next part of the service manual is the general tuning, and there's a tuning patch which is described in the service manual, and it has a few important features, one of which is that all the modulation is to be turned off. And I'll just set this aside. Note the pitch wheel is in the center position, modulation wheel is all the way down, and the LFO is essentially turned off. Sequencer in the off play position, arpeggiator is off, and we have retrigger in normal, repeat, normal. And curiously, in the service manual, it says the drone switch should be on. However, I disagree with that, and so we're going to leave that off. Glide should be off, and the frequency knobs for oscillator A and B should be at the 12 o'clock position, if you will. And we should be in triangle wave only, and sync off, low frequency disengaged, so we're in normal position for oscillator B. We're not using it as an LFO. And the keyboard should be off. And we'll describe the implications of that in a moment. Well, the implications are that for oscillator B, regardless of which keyboard position, or key rather, we press, we're getting the same note. And that's okay. That's what we want for the time being. Now, we're going to be looking at the tuning of both oscillator A and B. And currently, I have oscillator A and B in the 0 octave position. And that's not what is indicated in the service manual, but I wanted to do this in order to illustrate something. And that is to illustrate that if we look at the oscilloscope, whether we're playing oscillator A, which is what we're hearing here, then we go to oscillator B, we have essentially the same note. If we play them both at the same time, you can see that they're slightly out of tune, and so they're behaving such that there's a beat, if you will, as they come in and out of phase with one another. And I'm slowing down that beat as I bring oscillator A into tune because it's a little sharp relative to B. There. And you can see when they're very close to tune that they're additive, and that beating stops and it begins to resemble one waveform. And you can see as I detune it, that beating starts and increases in frequency. So the reason I wanted to both play that for you at this setting, but also show that to you and let you hear that beating, is because as we go through the tuning procedure, the service manual talks about the beating of the frequencies as they're in and out of tune. However, we're going to adjust the oscillator A octave setting to octave, actually oscillator B to octave 1, which is the position that is called for in the service manual. So that's bringing us up an octave. And so being brought up an octave, it means that the frequency of oscillator B is now twice that of what we were playing previously. So we're now playing approximately 62 hertz according to our digital oscilloscope, whereas here you see we've got about 31 hertz. So 62 hertz, but when we mix that with oscillator A, which is still at 30 hertz, we get a more complex pattern. And this is where it gets a little bit more tricky in terms of following the beating as these frequencies are in and out of tune, and where it may be advantageous to actually have an oscilloscope. So what we're to do is play the low C, and remember again, the keyboard position is off. This is at octave 1 and this is at octave 0. Play the low C and adjust oscillator A frequency, this knob, for 0 beat. that's about as close as we're going to get to a 0 beat. So the next thing we're supposed to be doing is playing a high C and adjusting the R128 oscillator A scale for less than 1 hertz of a beat. And that is the potentiometer beneath this little hole right here. It's a trimmer potentiometer. And so if we play a high C, so you may be able to hear that lower frequency rumble, that wah, 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 wah. That is the beating that we're referring to here. And what we want to do is adjust the oscillator A scale potentiometer located here. And what we're going to be using is a jeweler's screwdriver with about a 1 millimeter blade on it. And it helps if you actually look through the hole and locate the potentiometer until you get good solid purchase on it. And this is quite tricky. There we go. Around there. And then we repeat this. And this is a common motif in the tuning of these instruments, is it's an iterative process. So we play a low C again. And look for that 0 beat, and then we do the same with the high C. Okay, then we move to the oscillator A high trim, and we change oscillator A to the 3rd octave. Similarly, we move oscillator B to the 3rd octave, and we play a C0. And you can see the frequencies beating there on the oscilloscope, and you may be able to hear that. So that's very close to 0 beat condition, as they say. And now we play a high C and adjust the oscillator A high trim for 0 beat. An oscillator A high trim is right here adjacent to the frequency knob for oscillator A. So we'll position our screwdriver. And that's 0 beat. And what do we do again? We go back and play a low C. That's about as close as we'll get. There we go. That's 0 beat. So that's the oscillator A trim. Now we're looking to adjust the 1 volt trim. And to do this, we set oscillator A at 0 octave, oscillator B at 1, and hit a C0 and adjust oscillator A frequency for 0 beats. That's pretty darn close. And then we move oscillator A to the 3rd octave. And we presumably hit a C0 because the manual doesn't actually tell us what to play here. And what we're adjusting here is R1111, which is the 1 volt trim. And the 1 volt trim is located right here next to oscillator A. There we go. And then we repeat. Again, an iterative process. Go back to octave 0. That's essentially where it needs to be. 0 beat. Go up to octave 3. And that's a 0 beat position. So now we're adjusting octave B scale. So we set oscillator A to octave 1, oscillator B to octave 1, and set oscillator A to the 5 position. Switch oscillator B keyboard on now, and hit a C0 and adjust oscillator B frequency for 0 beat. So that's about 0 beat right there. And hit a C3 and adjust oscillator B scale trimmer for less than 1 hertz beating. And the oscillator B scale trimmer is located right here. So we're playing a C3 and adjusting for 0 beat. And that's about as close as we'll get. Again, that can be an iterative process. And now we're going to trim oscillator B high trim. And in order to do this, we move oscillator A to position 3, oscillator B to position 3, play C0, and adjust for 0 beat. And we're quite close. That's about right. And then play a C3, and now we're adjusting our 157 oscillator B high trim for 0 beats. And that is located right here to the right beneath the oscillator B frequency. So that's that positioned. Play a high C. And I think that's as close as we'll get. Okay, that's it for the oscillator B high trim. We're ready for the oscillator A B offset. And those of you with keen eyes may notice that there are side cheeks on the instrument. And that's because I'm doing this last part of the tuning a little after the first part of the tuning. The first thing that we do here is we make sure that our pitch wheel and our modulation wheel are in the middle here. Master tune is centered, and we turn frequency on oscillator 1 all the way to 0, and we turn the octave to octave 1. We are turning the B sawtooth off. We'll also turn this to 0. What we're to do is play oscillator A, and A only, and play the note A, A2, and we are to be tuning A2 to 440 hertz, A440, and we can see that we're nowhere near A440. We're actually at 217 hertz. And the way that we're supposed to get there is using this trimmer here. This is R120, the oscillator A offset. And so if we adjust this, we can see that we can't even get to 440. In reality, what we are supposed to be doing is doing this at octave 2, not octave 1. And that's 443. So that's about as close as we're going to get. And that's fine. That's fine for now. Because really what we're trying to do is make sure that the two oscillators are tuned to one another rather than any arbitrary number, because the tuning ultimately will be set by the master tune and these frequency knobs. So we then switch oscillator A to octave 3. We switch oscillator B to octave 3. We turn oscillator B frequency to 0. We switch on the sawtooth and we make sure that the keyboard is on. We play A2. And we adjust that for 0 beat at R140, which is this right next to the oscillator B frequency indicator on the modulation section. There we go. And so that is oscillator A and B set. And of course, we'll be able to tune these here and here on the master tune and the frequency of each individual oscillator. The next section in the tuning has us setting the amplifier balance and patching according to figure 5.2 in the service manual. And the first thing they do is say, increase the volume to a fairly high level. And so we'll turn it up all the way. And we set up a patch, which has us turning off the actual oscillators themselves. And so it doesn't really matter what octave they're set at, the pulse width, etc. We turn the LFO all the way up, although we leave the shape off. We have arpeggiation off, the sequencer off, and here we are supposed to be turning repeat on. And so this would give us normally a repeating note. And what we're looking for is minimal bleed through of the VCA. And this is adjusted using R138. Now we can see some bleed through on the digital oscilloscope, and I'll just change the settings slightly so that we get a better view of this. So we're not actually hearing this. We can begin to hear it there, and it's about 20 hertz. That's the VCA from the gate being turned off and on. And so what we want to do is adjust 138 so that we don't hear or see that. I'll turn it down. And the joke's on us in that there's no hole in the surface of the instrument to access this trimmer. It's behind here. And so notwithstanding the fact that we actually can hear that when we turn it up all the way, relative to the sound of the actual notes, it's very quiet. So we're just going to be leaving that there. So this is another example of an adjustment that really ought to be made while the main circuit board is out of the chassis, and cannot be made once the instrument is assembled. That's all for today's video. I hope you've enjoyed it. Be sure to check out our other videos on the Pro One, and if you like what you see, like and subscribe. Thanks for watching.